And now we can get started on the fun stuff. So today we have an 820-3023 that is not turning on. This is older than life itself. Tim Herman was probably still a fetus when this thing came out. This is an 820-3023. Sorry, Tim, but this is old. I have no idea why somebody would agree to get this fixed, but somebody did, probably in spite of our best efforts to convince them otherwise. So we're going to go through it. So this doesn't power on, and first thing that you'll notice is, well, it's dead. The fan is not spinning, and the light is not present in the charger. So the first thing we have to do is figure out why there's no light present in the charger. So I'm going to try and walk you through this circuit. You got quite a bunch of new viewership from the time that I was doing my other videos, so I should go over how these circuits work again, just for those of you who are new. So let's fire up the schematic and get to it. Now, in order for you to get a light on the charger has to talk to a chip on the motherboard. This is a smart charger. It's not like those PC chargers that are usually dumb and don't have any type of communication. It wants to speak to something. So that's going to happen over here. Now this looks really confusing, but let me just try and narrow it down so it's less. So this is the charging port, right? You have 20 volts, that's your charger. You have ground, and then you have adapter sense. Adapter sense is going to be the line upon which the charger, right over here on the charge port, this is the charge port, talks to the computer. Now, instead of and that's going to happen on this line called sys1 wire. So adapter sense is going to go blip, blip, and bi over here stands for bidirectional data line. And you just copy one wire, and you'll see that that goes to a chip called the SMC, U5000. See? It's going to go right here. Sys1 wire, bidirectional data line to U5000, which is, as you can see down here, the SMC. This is the SMC. I'm sure they're fine with me using it to fix their stuff. Apple loves me. Anyway, so we continue. So that is, this communication has to occur. U5000 needs to talk to the charger. So that, now there's a reason that we don't tie the adapter sense line on the charger straight to the SMC, and that's simple. This is a data line, right? And this is a data line that operates on 3.42 volts. So if you were to measure this side of this resistor when everything's working, it's 3.42 volts. And this resistor is going to pull that signal up. So it goes something like this. So every time one of these chips wants to talk, it's going to short that data line to ground. So let's say you have 3.42 volts. So it's like da, and 0 volt is down here. You can have communication between those two. But if there's no pull-up resistor and there's no 3 volts, then there's nothing to pull down, which means you have nothing to write on. It's kind of like if you're writing on a piece of paper on loose leaf, you need a top line, bottom line, you write in the middle. So that works off of 3.42 volts. Now the problem comes in when you're drunk. So let's say some drunkard comes by and is trying to plug in their MacBook after some late night gig to make some more music. It's like, ugh, they're just falling all over themselves like doing this, and it doesn't want to charge. Well, what do you think is going to happen? What would probably happen in that case is the drunk person, plugging it in improperly, may let the 20 volt section of their charger hit where the adapter sense pin is going to be. And that's not good, because if 20 volts goes to the circuit that's expecting 3 volts of data, then it goes. So in order to keep that from happening, we have U7000. So the way U7000 works is it's a buffer between external, as in your charger is external because it's outside the computer, and the SMC, internal, because the SMC chip is inside the computer. So the way this chip works is it says, hi, are you a 3.42 volt data line? Come right in. Are you 20 volts of DC? And that's the way that works. So it keeps that 20 volts of DC from going there if some drunk dude is like doing this, trying to plug it in. It's called one-wire protection. Now, in order for this chip to work, it needs to get voltage on its VCC pin. A lot of these chips here are going to have pins on them that are for power input. And they're usually at the top when it comes to anything that starts with a U, anything that's one of these little IC chips, integrated circuits. So it's going to be V in for voltage in, VCC, VDD, something like that. But you need to have voltage up here at the top for it to turn on. So for example, this is my microscope camera right here. This is the power adapter that plugs into the wall, and I'm plugging it in. So what I did there is I just plugged in my voltage in or VCC or VDD pin. From my phone even. You may call this the VCC or the VDD pin. All that means is the power that's needed for the thing to turn on. So this chip up here needs that. This chip needs 3.42 volts at its VCC pin, or it won't turn on. But what turns this chip on? What turns this chip on is going to be the voltage that comes from this line. So we got to follow this line. Where does it go? Okay, so it goes left and right. So if we follow this up and we go to the left, it goes to a capacitor, which then goes to ground. Ground is 0 volts, ground is nothing. So this can't be it. It's not that. That's not powering the chip. All right, let's go on. But over here, we have a line. Ooh, it goes to a 2 kilo ohm resistor that then goes to a data line. And data lines don't power chips, so that's not it. We need power, so that's not it. So then we go back over here and we go, and up here, this is a logic gate. Okay, maybe this does it. So this is a logic gate that's powered by Pepe3v42_G3 hot. So the way this works is this logic gate is going to take 3.42 volts and shoot it out. So if A and B are present, then you get Y. So this chip is going to pass through Pepe3v42_G3 hot if SMC, BC, ACOK is present. So what are the important things here in order to get a green light? Well, the first thing that we need is for this chip to turn on. For this chip to turn on, this chip needs to turn on. For this chip to turn on, we need SMC, BC, ACOK, and PP3V42. So in order to get a green light, we need PP3V42 and SMC, BC, ACOK. Now the Air makes this a little bit trickier. The reason the Air makes this trickier is because it's not in the schematic. We're actually looking at a schematic to a Retina board. If you look over here on the Air schematic for the machine that we have in front of us, you'll notice that Sys1 wire goes to a connector called J4700, and then it goes over here to U4900, which is the SMC. But you never get to see any of those chips. And the reason that is because on the MacBook Airs, all of that circuitry is contained on the DC in board, not the main logic board. And the schematics that we can find are only for the main logic board. So it's important that you understand how this circuit works before you get into troubleshooting the MacBook Air. Because if you don't know how the one-wire circuit works on a normal board, then you're never going to figure it out in a MacBook Air board because those components are not even included in the schematic. But if we know what they look like on a normal board, then we can find them on a MacBook Air board. So if we were to look on the schematic for the older devices, like the one that I just showed you, we'll be able to see what these two components look like. So, according to the schematic, for the older device, the Retina that I showed you, this here is, let's see, U7000, and this here is U7001. This is a fairly beaten up donor board, but I'm just using it to show you. So this would be U7000, and that's U7001. Now we know that the one-wire circuit on this MacBook Air is going to be on the DC in board. So we're going to take a look for that. See if we could find it. Let's see what we have. So I'm going to drag my microscope over, and let's see if we see anything that looks similar, familiar. Anything at all? So we do have a DC in board, and our DC in board, as you can see, looks quite nasty. It looks very nasty. Ew. Looks like garbage, actually. Ugh. Gross. Yuck. Ew. Blah. Anyway, shouldn't get obsessed with that. It's just another day at work. Touching things that people probably tossed in the toilet or whatever. So we're going to remove the DC in board, take a look at that, and see if we can find out where that one-wire circuit's hiding. Because it may be hiding on the other side of the machine. And go from there. That is not the dumbest ringtone. So anybody notice the ringtones that get included with Android phones on Verizon nowadays are such garbage? So, I think we got him. Okay, time to silence that phone. That is the dumbest ringtone. Jesus Christ. Yeah. So, we look down here. And what do you know? Looks like we got our one-wire circuit. So, well, one of the things we need is for Pepe3v42_G3hot to make its way there. So I'm just going to take the board out of the machine, plug it in, and see if we're able to get that. First thing I got to do is take the board out. Where is the Italian guy? I am the Italian guy. All right. So let's get the multimeter on. Let's get the software on so you can see it on the screen. Yeah, look at that. We fancy. Okay. And let's see if we're getting our voltage where we're supposed to. So I need to get PP3V42 G3 hot in order for this to work. So let's see if we have PP3V42. Why do you answer the phone hello instead of Rossmann Group or something professional sounding? I think hello is quite professional sounding. Fuck off would be unprofessional sounding. I used to answer the phone Rossmann Group, how can I help you? And when I answered the phone Rossmann Group, how can I help you? What people would do is they would say, hi, is this Rossmann Group? And that happened enough times that I just said, fuck it, I'm just going to say hi. Like, I'm going to say, Rossmann Repair, how can I help you? And then they say, hi, is this Rossmann Repair? It's like, what the fuck did I just say? So I gave up at some point. It's like, fuck it, I'm just going to say hello. Hello works for me. Like, I figure if they're going to ask anyway, because when I say hello and somebody says, is this Rossmann Repair? I don't get that little kick of like, well, what kind of idiot are you? Because that kind of sets me into it's silly, but like if you're going to answer the phone, let's say 600 times in a day, then you have to figure out ways to answer the phone that are not going to, where the small annoying aspects of it aren't going to aggravate you. So if I say Rossmann Repair, how can I help you? And they say, is this Rossmann Repair? The first thing that comes into my head is, man, you're dumb. And that sets the tone of the conversation negatively. So I try to do things that don't set the tone of the conversation negatively, particularly because I'm not really a call center type person. Anyway, so it looks like we're getting 1.29 volts. So that 1.29 is not 3.42. We're supposed to be getting 3.42 volts there. So I am going to look up where that is on the schematic. So let's try and figure out what creates the 3.42 volt power supply and go from there. So let's look that up. Yeah, I'm not really a call center person. I would get fired from a call center very quickly. Like it's different answering the phone for myself because I'm answering the phone for my business, but so I have the liberty of kind of coming up with a way to answer the phone and speak so that I limit my frustration. And that definitely helps. That definitely helps. Or the worst was I used to work at Modell's Sporting Goods, and they used to make us say, welcome to Modell's Sporting Goods, your hometown sporting goods store. How may we assist you today? They actually expected us to say that for $6 an hour. Welcome to Modell's Sporting Goods, your hometown sporting goods store. How can we assist you today? It's like, no, hello, or sporting goods. Like, I just answered the phone sporting goods. You know, you can fire me and replace me. I'm not saying that shit. That used to drive me up a damn wall. Welcome to Modell's, your hometown sport. What the Wesley Van Pelt makes a good point. I wonder how Model Sporting Goods is doing. Okay. So, .42 volts. That's right here. This is the 3.42 volt supply. Now, the 3.42 volt supply has to be on before anything else works. It's what the SMC runs off of. It's important. So this is one of the few rails that has to be present before everything else, which means that it needs to have two inputs, the battery and the charger. Now you see a diode over here, and there's a reason for this. So Pipibus G3 Hot is a power rail that's either from the battery or created by the charger. And this over here is the charger. So this becomes a problem. So we can't tie the two together, because if we tie the two together, that means that we would be sending the 18 volts from the charger to the battery. The diode sits here to keep the voltage from the charger from entering the battery. So if the battery is not plugged into the computer, PP3V42 will be powered by the charger. If the battery is plugged into the computer and the charger is not plugged in, the 3.42 volt line will be powered by the battery. If the battery is plugged in and the charger is plugged in, the machine will be, the 3.42 volt rail will be powered by the charger, but, and this is an important one, that charger voltage will not be allowed to go back into the battery because of the diode existing. Do your employees get away with answering hello too? I mean, they can if they want, as long as they answer people's questions and they're somewhat cheerful, and, you know, I don't really care what they say. Like if they say, you know, I don't want them saying like, what do you want? You know, that's BS, but I mean, whatever works if you're answering the phone 600 times a day. I'm not making them say like, welcome to Rossman Repair, your hometown repair shop. HAKKO. Like, no, I'm not. Fuck that. I can't believe that. I can't believe somebody ever actually expected people who made $6 an hour to say that. Like, you're lucky we damn near show up to work much. Anyway, so let's find that area, let's find the circuit, and let's try and figure out what's wrong with it. So we're going to go up to the board view software here, which is going to show us where that is. So the first thing I want to do is find that chip, and that chip was U6990. So we have to find it on the donor board. U6990. And that's going to be right here. Right here. Not a pretty area, is it? Looks pretty messed up. So we got to try and figure out what's going on. So the first thing I want to do is their voltage on input. So I'm going to check right over here on pin 6 of the IC where it says voltage in. And we're going to see if we're getting the voltage in that we need for this to turn on and work. So I got my multimeter probes. I got my multimeter showing up on screen all fancy. Say something nice to G. I don't know if I have the ability to say something nice to 4chan. 4chan never says anything nice to me. Well, for $2, I should probably say something nice to G. I suppose by not saying something mean to G, I'll have been saying something nice to G. Why not just pick up the phone with bada bing? That's a good one. Maybe I should. I have to practice my Staten Island accent. Why aren't you streaming on Twitch? Because I reset my stream key and I forgot to put it on restream. The 6 people that watch my Twitch stream will miss out on it. I work for $2.50 an hour. Well, I hope you were able to negotiate not answering the phone annoyingly. You missed a donation from Wesley. Huh. How's that New Year's resolution going? Oh no, I saw it. I saw it. I'm aware of how bad my New Year's resolution is going. Okay, so back to what's important. Pin 6. Pin 6 is the voltage in pin, and we need pin 6, which is the voltage in pin, to be getting 18 volts from the charger. So let's check that out. That's right here. And it looks like it's getting 18 volts. That's a good thing. Okay, so we're going to move on. Now the next thing to do is to try and see if the output is short-circuited to ground. So before we do any type of resistance measurements, we're going to turn the power off. Do this. Do this. And it looks like we have 9.83 kilo ohms of resistance. 9,000 ohms is not as short to ground.
9 million ohms.
9 million? So.
A small $1 million loan.
Small $1 million loan. Small 9,000 ohm loan. Oh, man. So we don't have a short to ground. So now let's just think about what our issue is here. Our issue is not that the power rail is missing. We have the power rail. The power rail is there. It's 1.32 volts. It's not 0 volts. And the issue is also not a lack of input. Keep up the good work, man. Thank you to Charles Wang. The issue is not that the power rail is missing. It's there partially. It's not short-circuited to ground because it's 9,000 ohms. And the input voltage is there. So this leaves us to two possible conclusions. Behind door number 1, the chip creating the rail is bad, and it's not regulating it properly. Behind door number 2, some process outside of the chip that's responsible for regulating the precise voltage is not working properly, causing the voltage to be low. Now, one of the processes that's going to regulate the voltage of a chip is something called feedback. Now, let's say you're driving on the road. You being able to see through the windshield is feedback. If your windshield were to become entirely covered with snow, then you wouldn't be able to see. What's one of the things you would do if you can't see? You'd probably drive slower or stop altogether. The chip also has a way of seeing what it's creating. So the way that this chip is going to work is it's going to pulse back and forth. It's going to twerk back and forth. And the chip, through its twerking, is going to take the 18 volts from the input and it's going to slice it up. So over here you can have 18 volts, 0 volts, 18 volts, 0 volts, 18 volts, 0 volts, 18 volts, 0 volts, 18 volts, 0 volts. And then through this coil, it's then going to get averaged out into 3.42 volts. And that's why this is called SW. This is called SW for switch. Now, one of the things you need to know here is how often should we switch? Should I switch faster? Should I switch slower? Well, the way it's going to tell that is by looking at the output. It wants to see what it's creating. And that's what FB is here for. FB is for feedback. It wants to see what it's doing. It wants to see where it's driving, the same way that you want to see out the window. Now, the way that this is going to be accomplished is through R6995 and R6996. This is a voltage divider. So the way this works is that one resistor goes between output and your destination, which is R6995. R6995 sits between here and destination. And then your second resistor is going to sit between destination and ground. A voltage divider lowers your voltage. So the idea with the voltage divider is that it's going to send a little bit to feedback so you can see what it's doing. Now, what are the cases within which the chip is going to produce less voltage? So if the chip thinks it's creating too much voltage, it may adjust itself to produce less. Spend a couple of bucks on dinner tonight, says Flying Guy SFO. Thank you. I appreciate that. Thank you. It's very nice of you. So over here, this is supposed to lower the voltage. R6995 and R6996, this is a voltage divider. Now let's say that R6996 died. This went away. This stopped working and stopped conducting to ground. R6995 would be directly tying this to feedback, and without R6996 going to ground, the voltage would not be lowered at this feedback pin. That would mean that the feedback pin is receiving a voltage that's too high. If the feedback voltage was too high, then the chip may compensate by slowing down the switching process, therefore producing less voltage. So suspect number 1 is that C6995 is shorted, which means that all of this is going to feedback, so feedback is too high, or R6996 is bad. If R6996 is bad or doesn't have a path to ground, then all of the voltage from here will end up at feedback. That's one of my hypotheses, something going funky in the feedback circuit. The second hypothesis is that the chip itself is bad. So let's take a look back on the board and let's find these few. So we're going to go back here and check out R6996, R6995, and C6995. R6996, R6995, C6995. And go from there. Let's get a better view. How many gingerly boards do you get in a month? Huh. Gingerly.
How many gingers?
Oh, look, it censored it. See?
How many gingers?
I would say about 5, probably 5 that are truly nasty. I would say I get 5 that are truly gingerly. All right, so it looks like pin 2 of R6995 leads to this over here. See this? And this was corroded. This has green stuff on it. That has gingerly stuff on it, as the censoring algorithm would say. Okay. So R6995 is supposed to be 348 kiloohms. And that's here. Oh, you can't see because I didn't put the meter on right. Whoops. All right, so the meter software is garbage, so it's not registering on the screen. But what I'm getting over here is 164. There we go. It's registering on the screen. Beautiful. And up here, for the second resistor, I should be getting 200 kiloohms. And I'm getting 140 around there. All right. It's going up. So that seems to be working properly as well. Huh. That's an interesting one. So now the next thing I want to do is I want to check the connection between pin 2 of R6995 and pin 1 of R6996. Pin 2 of R6995 and pin 1 of R6996. Let's check that and see if that is connected. And they are. That's weird. This is probably that funny moment where I'm going to turn it on and it's going to work. And holy crap, that's all I had to do. I had to scrape that little piece. So this over here was connecting this resistor to that resistor inside the board. And by scraping this, I literally got it to turn on. Like, I'm not kidding. Wow, look at this. So before we did not have a light, and now we have a light on the charger. Expose yourself to the board and it will turn on. I mean, that was what I was going to try next. Trust me. And I'm going to check CPU vCore now. Let's check CPU vCore to see if this thing is actually turning on. Nope, it turned off. Damn. All right, so we got to back to the drawing board. Back to the drawing board. Okay. First question. Let's go. Damn, that almost worked for a minute. Are we getting PP3 V4 too? Nope. 1.8. Okay, so I think the first thing to do is to reconnect that area of the board. Go over these nasty probe points. Also may restart this crappy multimeter software. Yeah. I'm getting 1.8 volts, and the dumbass B&K precision multimeter software that never works right is showing 62 volts on screen. I have no idea why this software is as terrible as it is for how much money this multimeter costs. B&K should be completely ashamed of themselves for allowing this product to exist at the price that it does. But anyway, so let's run over that point a little bit. Some solder and some flux. Make it nice and pretty. So I'm gonna be having a guest on shortly. Right after I had this issue with Yelp where this employee was sharing my friend's personal data. I pointed this out. She gets fired. She has her best friend, who was, like best friend in class on Facebook and in Yelp and LinkedIn and all that, leave a bad review using her Yelp Elite account that was totally fake. And I managed to go through and prove that it was a fake review, and then it wound up getting removed. And then she had her Yelp account deleted. And somebody came to interview me. Her name was Kaylee Milliken, about a movie called $1 Billion Bully. And it's been about almost 2 years in production, but she's finally ready to screen it. So I'm going to be having her on for an interview soon, along with the associate producer. So that should be fun. That should be fun. Hope to see you all around for that. That should be I might just wind up replacing that chip as well. I don't really trust it. Yeah, let's just go for it. Let's tear it right off. This area was corroded and nasty, and that chip's just a few dollars, so. What magnification is this microscope running at? Right now about 13 or 14x. Paul did make some software, it's just I don't know where to get it. He sent me one revision of it and I couldn't figure out how to use it because I'm an idiot. So I'm eventually gonna try Paul Daniels' newer revision. Hopefully I have a brain for it. Hey, how's it going? Have a seat.
Well, I know you saw me, but how are you?
Yeah, yours will be next. Okay. This is the wrong tip for this, but what the hell. Found a laptop yesterday that had the ballast circuit for the CFL arc over to the aluminum case and the fuse didn't go off. Huh. Was it an Apple? That would kind of... Alright, so let's see. Oh, this is one of those chips that doesn't have a dot or a circle on it. You bastards. Alright. Okay, LDOR. Oh, that's lame. I guess they have the underline. You should put a dot there. How do you... Joseph says, I discovered this the other day and binge watched a bunch. I've never owned anything from Apple. Sounds like you're ahead of the game already. What do you do, Krish? Michael Nance says, I don't allow people to bring Apple products on my property. That seems like you're going a little overboard. Right. Okay, now to get my micro tip to finish it. Paul stole my micro tip. Just because I stole his does not make that fair. I appreciate your $2, but you're asking a little bit too much for your $2. What do you think this is? A Vernon Jackson strip club or something? All right. Show me a light. Okay, let's see if we have CPU V-Core. That circuit looks pretty nice. We go over here. Measure at the coil. Hey, it's turning on. We have V-Core, which means I'm done. That's quality assurance testing we do here. All right, so next up, what did you bring?